Hey everybody, welcome to Mathematical Production. Today we're going to be going over how to use the quotient rule to solve for derivatives. So you want to use the quotient rule whenever you're taking the derivative, for example, of two functions that are being divided by each other. So if you have a function in the numerator and you have a function in the denominator, and you can't further simplify it. So the quotient rule states that whenever you have this situation, what you want to do is take your denominator function, multiply it by the derivative of your numerator function, subtract it by your numerator function, and multiply it by the derivative of your denominator function. And we denote the numerator function as f of x and denominator function as g of x. And then you want to take this and put it all over the square of your denominator function. So this is the quotient rule. And a simpler way to remember it is low d high minus high d low over the square of what's below, where low is your g of x and high is your f of x. So let me write it out real quick. Low d high minus high d low over the square of what's below. And now that we stated the rules for the quotient rule, let's go ahead and work out a problem. So our example for today is going to be taking the derivative of sine of x over x squared plus 3x plus 5. So the first thing you want to do is identify all of your functions, so f of x and g of x, and take the derivative of those. So f of x is your numerator, and that's just going to be sine of x. G of x is your denominator, and that's going to be x squared plus 3x plus 5. So now you want to go ahead and take the derivative of both of these functions, since we're going to use it anyways. So the derivative of f of x is the derivative of sine of x, and derivative of sine is cosine. All right. And now the derivative of x squared plus 3x plus 5, let's take it one term at a time. The derivative of x squared is 2x plus the derivative of 3x, which is just 3, and derivative of 5 is 0 because derivative of any constant is always 0. So now that we got all of our terms, let's go ahead and plug it into our formula, right? So low d high minus high d low over the square of what's below. So low is just g of x, and we already found that to be x squared plus 3x plus 5, and I like to group it while I'm writing it out in parentheses. All right, so low d high is derivative of f of x, and that's going to be cosine of x, minus high d low minus high, and high is just f of x, which is sine of x in our example, and d low is derivative of low, which is just 2x plus 3 over the square of what's below. So now you want to take the square of g of x. And normally when I'm working out these type of problems in my calculus class, they allow me to leave the answer as this, and they didn't really require us to simplify it or expand it, because that would be a lot of work and it's not really relevant to what you're doing here. All right, so this will be our final answer. You could simplify it if you want, but typically they just accept it as is. And another thing to note is, if you're using the quotient rule and you don't feel comfortable with it and you're more comfortable with the product rule, typically you could always rewrite a quotient as a product. So let's say you're taking the derivative of f of x over g of x. Well, g of x can be brought to the numerator if you raise it to the power of -1. And that's an exponent rule. So if you raise g of x to the power of -1, instead of using the quotient rule, you can now use the product rule. And personally, I don't like using the quotient rule, so this is kind of what I do on the day-to-day. So if we were to do this with the problem that we were working before, instead of taking the derivative of sine of x over x squared plus 3x plus 5, you can also just take the derivative of sine of x times x squared plus 3x plus 5 raised to the power of -1. So in some situations it's faster, some situations it's actually slower. So it just depends, and you just got to use your insight to predict whether it's faster or slower. So in this situation, actually might be a little bit slower or a little bit faster. Like I said, it depends. Another thing to note is that when you're doing the product rule and you use this, you're also going to have to use the chain rule because of the -1 and the function being raised to a -1. All right, if you found this video helpful, make sure to like, comment, and subscribe, and have a great day.